Synthetic division is a shorthand algorithm to divide a polynomial by a binomial of the form x minus k. So, in other words, this is a shortcut. This is a way quicker and also easier method to perform polynomial division, but we can only use it when we're dividing by a binomial, and that binomial can only be one where the x term is a linear term, not squared or higher. And this is how we do it. Look at our example. We want to divide 4x squared plus 5x minus 4 by x plus 1. So we fill in our numbers and we only fill in the coefficients. So on the outside here we put our divisor, or we put our k. In other words, it's the opposite of the number that we had in our parentheses here, x plus 1. The opposite of that is negative 1. And on the inside of our box, we only put the coefficients of our terms, 4, 5, and negative 4. And now, this is what we do. The first term, we bring down 4. And then we multiply the negative 1 by the 4. We get negative 4, put it here. Then we add 5 and negative 4 to get 1. Multiply the negative 1 by the 1 to get negative 1. And then we add the negative 4 and the negative 1, and we get negative 5. The negative 5 back here is the same that we've seen before. This is our remainder. So let's now translate the result of this operation into a final trinomial. We started by an x squared term that got divided by an x. So that means we take down the exponent by 1. So we now have 4x. The 5x got divided by an x, so there's no more x left. That means we have 1. And our remainder, negative 5, we put, just like we did before, over our divisor. 4x plus 1 plus negative 5 divided by x plus 1 is the result of our operation. Synthetic division is a nice way to evaluate functions, and it also helps us to factor higher order polynomials. And both those things we'll explore some more in our next examples. The remainder theorem is the rule that helps us use synthetic division for evaluating functions. When we're dividing a polynomial f of x by x minus k, then f of k is equal to r, where r is the remainder. Let's look at what this means. We want to evaluate f of 3 for f of x is equal to 2x to the 4th power plus 3x squared minus 2x plus 1. So if we want to find out f of 3, 3 is the number that goes on the outside, and now we're going to fill in the coefficients of all our terms, but be careful here. We got 2 as the coefficient of the quartic term. Before we fill in the 3, let's realize that this is the coefficient of the square term. So just like in the long division, we need to fill in a missing term. 0 is the coefficient of a cubic term that's not existing. Then we fill in the 3, the negative 2, and the 1. So we're bringing down our first coefficient 2, and now we start multiplying the 3 by the 2 to get 6. Add these two together, we get 6. 3 times 6 is 18. Adding 3 plus 18 is 21. 3 times 21 is 63. Adding negative 2 and 63, we get 61. 3 times 61 is 183. 183 plus 1 is 184. and 84. Just as in our previous example, 184 is the remainder, and based on the remainder theorem, it's also the value of f of 3. We can check our result by using the calculator and plugging in the equation. I've already done that here. Here's the equation, and if I now go to the table of values, I see that for x is equal to 3, y is equal to 184. That's exactly what we got in our synthetic division. So the calculator check showed us that we did the work correctly. It's always a good idea to check our work and make sure that we didn't make any mistakes. Let's talk about the factor theorem. If f of k is equal to 0, then x minus k is a factor of f of x. Factor f of x is equal to x cubed minus x squared minus 21x plus 45, given that x plus 5 is a factor. We can set up our operation for synthetic division. Since we have a factor of x plus 5, we need to use the opposite of that. Negative 5 goes on the outside, and fill in our coefficients. Positive 1, negative 1, negative 21, and 45. We bring down the 1, then multiply negative 5 for 1 to get negative 5. Add negative 1 and negative 5 to get negative 6. Multiply negative 5 by negative 6 to get 30. Add negative 21 plus 30 to get 9. Multiply negative 5 by 9 to get negative 45. 45 plus negative 45 is 0. So we know that f of negative 5 is 0. In other words, this is a 0 of our function, and x plus 5 was one of the factors. So let's sum the result of our synthetic division. We divided a polynomial starting with x cubed by a binomial with x, the linear x. So our result starts with an x squared, 1x squared minus 6x plus 9, and there's no remainder. So you really should think about what we do with our polynomial division. We peel off a layer of exponents from every one of the terms, almost like peeling an onion layer by layer. And we can now rewrite our function f of x. F of x is equal to x plus 5 times x squared minus 6x plus 9. Since we're supposed to factor this, let's look at our trinomial in the back of this function. And we see we got a target sum of negative 6, target product of 9, and that helps us and gives us the two numbers negative 3 two times. So we can write our fully factored function f of x is equal to x plus 5 times x minus 3 times x minus 3, and our x-intercepts are therefore negative 5 and 0, and the other one is 3 and 0, and that is a double root. Let's try one more like these. factor f of x is equal to x cubed minus 5x squared minus 2x plus 24. Given that x plus 2 is a factor. If x plus 2 is a factor, then we're saying k is negative 2. And that's what we're going to use for our synthetic division. Negative 2 goes on the outside. And our coefficients are 1, negative 5, negative 2, and 24. We bring down the 1 and then start multiplying. Negative 2 times 1 is negative 2. Add negative 5 and negative 2, we get negative 7. Negative 2 times negative 7 is positive 14. Negative 2 plus 14 is 12. Negative 2 times 12 is negative 24. 24 plus negative 24 is 0. So now then f of x is equal to, first of all, we got x plus 2, which was one of our factors, and the remaining trinomial is of the form x squared minus 7x plus 12. Let's see if we can factor that. Target sum is negative 7. Target product is 12. And that gives us the two numbers, negative 3 and negative 4. So then we can write the fully factored function f of x is equal to x plus 2 times x minus 3 times x minus 4. And that leaves us with 3 zeros. The zeros of this function are x is equal to negative 2, remember to switch the signs each time, positive 3, and positive 4. Alright, that's how we do it when we have one factor already given. And in the next class we will discuss how to use this method when we do not have the first factor already given to us. Alright, that's it, and I will see you in class.